All right, so it's March 4th. This is the last class of the day, doing a recording of the lecture for everybody. Here we are in Moodle. I already got up a 30-minute video on the first script of how to connect the clock to the sun. I'll show you how I kind of got two methods right now, and I'm going to eventually just combine them into the two scripts together and give like more features for moving the sun and clicking on the clock to update the time. And note that we have basically 2 full weeks of work and then spring break, and you're expected to deliver on your sprint 2. And I'm not telling you what to do every week. I just assume from the first sprint that you've been trained. Here's the diagrams, if you remember them. So previous week, I posted videos on revisiting diagramming, creating the new user flows, and I did some updates to my user interface. So I'm going to cover aspects of this to start off the class, and then I'm going to move into how to update the prefabs to have this kind of glowing transparency, and how to have the time not only impact the clock, but impact the sun. And then the rest of the videos for the week will be diving into those clock scripts more of what I'm about to show you, what the features I'm creating. So just remember, as you do your drop, you're supposed to have a project description, you're supposed to have your user flow diagrams, and a link to your project on itch.io. So for this class, if I click play, I'll just give you a preview of what we need to talk about in class and what we're going to talk about out of class. So if you notice, if I click on my click detector, these objects now kind of have a transparency to them, and they have kind of a glow to them. So if I increase this emission strength, they're like glowing stronger. So if I change my time, turn off real time, and I make it like really dark, something like this, and I go back to painting the strokes, notice how they kind of fit in that nighttime better. They're kind of these glowing lanterns type deal. And I can lower down the emission strength, and notice how they're not like glowing, but they still have a transparency to them, but they're kind of hard to see in the nighttime. So if I ramp up the emission strength, notice how they're like glowing, and they kind of fit into that environment. So I'm going to show you how to update your prefab, your painted objects, to do this. Right now, I just have it connected to this developer interface, but eventually I'm going to have the time of day drive this so that these objects glow strongly when the user wants to paint in the nighttime. And if the user wants to paint in the daytime, that I'll reduce the emission strength, and they won't be glowing as much. Let's switch over to something. There we go. And maybe I'll open up the transparency part of it as well. But for just this week, I need to show you how to update these objects to have these capabilities. And then I'm going to move into the time of day, how I can change it with this slider. And I also have this other feature I'm developing where I can click on the hour hands, and we can move throughout the cycle. And if I click here, I'm switching the 12-hour cycle between AM, PM. And if I click back in time, I'm actually cycling to the next part of the day. So as I move forward, we're just moving forward a few hours. But if you click backwards in time, I thought it didn't make sense to go backwards in time. We're just going to move forward. So we're moving from like AM to PM as you go back in time. So this is going to be covered with the online part of the lectures. But let me start off with covering, recapping the user interface updates from last week. And let me cover the painted objects now have this kind of glow, emission, transparency. And I got to cover now that, I don't know if you remember that issue I was having last week where when I click on the clock face, it was like deleting parts of it because the default behavior we had in our script was if you click on something, delete it. But now I have to specify, oh, no, these objects are painted objects. We could delete them, or these objects are part of the clock. I want you to update my time. I don't want you to delete them. So let's step back, review last week. We have these red, green, and blue sliders that change not only the color of the paint stroke, but the actual interface elements update to show how much you're changing the slider. How's it impacting the color information? So as I change this slider, not only is it changing the color floats in my click position manager script, but this interface element, this passive element, it's not interactable, it's not clickable. The time, the amount of this paint stroke is actually updating. And I did the same up here. How long do you want your time destroy to happen? So I want it to be at 1 second. Nope, I want it to be really long at 5 seconds. And that passive information is updated in my user interface. So I am going to shrink up. I'm going to just pull my hierarchy up here. I don't need my project view for right now. So in the hierarchy, if I open up the canvas, I'm going to shrink up all these. This is what it should look, something like this. We have the red, green, and blue sliders. So if I open up the green, I showed you that this is where we were. We started with, we just had a slider. It was connecting to our input script so that when the slider values changed, it changed the colors that would be randomly spawned on these new objects. But the only input, the only information back to the user had to deal with like where the slider is, and when they paint, they'll see this color feedback. So I wanted to add these text elements to give some more information back to the user. So all they are is if I go gameobject UI button, and then drag this button into my hierarchy for my green slider so that it's all kind of together. I can find it easily. I'm going to move this button up. I'm going to move it over, and I'm going to recreate this text element, but on the right side. So this button by this element by default is interactable, and the only reason I did a button is because I want this image background. You see how the text is kind of hard to read by itself, so I want this button to be just a graphic. So I'm actually going to remove the button component. It's not interactable right now. It's just an image basically. So if I open up the hierarchy, we have the text here. So I usually call it something. So in this case, I'll say text green 02 so that later on it's easy to find, it's easy to reference. And now I have to determine what type of information do I want to present to the user. So these floats range from 0 to 1 because we clamped them down to those specific values with our user interface element. But 0 to 1 doesn't make a lot of sense for the user to feed back on. So the values, if I just fed them right back to the user, would be like 0.12345 or 0.769 based on going from 0 to 1 in decimal format. But I want something more like integers going from 0 to 100. Users usually know about a percentage going up to 100. So to me, if I put 100 in there as just a default placeholder, since the slider defaults to 1, meaning fully on, I think the easiest information to convey back to the user that it's fully on would be 100 if we move from 0 to 100. So the buttons originally had something said like red, green, blue to specify, oh, what I'm actually interacting with. Well, I don't need to actually state that to the user. I can take the color information of this background and adjust it, and this can be the way that we tell the user that this slider is really impacting this color channel. And since there's a painting app and the only real thing you can do is actually like spawn these objects, it makes sense for them to say like, oh, this is the color that's connected with these objects that are spawning. So if I go through here and just zero out red and blue and just leave it at green, I don't need to say green anymore. I can use that area, that space of my interface to be more dynamic, convey information more precisely to the user. So I can actually have a range there from 0 to 100 instead of saying red, green, blue. So I'll default it to 100. Not only does our slider default to that, but that's the largest that our text is ever going to be in this button area. So I know it's going to go from 0 to 100. So I can size up this graphic now on 100. So whatever feels the most comfortable boundary size, I can scale up my graphic around it. So I can select the color, I can scale it up, and I know that whatever number goes in here between 0 and 100, it'll fit in this little rectangle nicely. So now that I have my size, my proportion, my text. Oh, I'm not there yet. So I'm just, yeah, I'm going to show you. So how am I going from a float, 0 to 1, to more of an integer, 0 to 100? Yep, I'm going to get into the script yet. So can you just close the door? So I'm just, right now I'm figuring out that this is a user interface element. I'm figuring out the information that I want to present to the user that makes the most sense. And then I'm kind of scaling everything and positioning, make sure it's like nicely laid out. It's not taking too much space. So I built it, I colored it. You could also change the color of the text if you wanted to. So here it's white, here it's black. What your primary responsibility is to make it as legible as you want. So I could make the background white and make the text green. That's up to you. In this case, since the text is all black, I said let's just make the background green. But you can manipulate these colors to start with in a static way, and you can also grab them with code and dynamically update them. But let's just say I'm happy with this current element, and I also made it a child of this slider, so that if I do need to move this slider or this green aspect of my user interface, they all come along for the road. I don't need to move them all one at a time, and it's a very cumbersome process to reconnect them all. So if you remember that the slider goes from 0 to 1, defaults at 1, and whenever we change it, it calls this script, this change green. So if I come down here, here is that method that we call change green. So you know that we pass in this temp float, this float variable that only exists in this method. And we receive that from the slider that the user is changing. And we update our green float to that. Our green float, it's a private float, and we use it here when we're figuring out the random color that we're going to apply to our next paint stroke, our next paint object. And that number we specifically keep to between 0 and 1. So that's fine. Now this is new, and this is how I'm actually updating that text element to be between 0 and 100. So before we update something, we have to know about it. So if I go up here, I have these public text variables. Text is a class provided to you from Unity. You actually have to do this using Unity engine.ui. And then we have classes available to us that are about the UI. One of them is text. And so I made these, the mouse position you were aware of, and I just made these blue amount, red amount, green amount. And when I save this, you're going to want to connect them. So if I click on click detector here, here's blue amount, red amount, green amount, and they're looking for user interface text components. So I've already connected them. So this text green, for example, I'm going to connect the right one and update that one and show you that since I've built it the same way as I built the others, we can just connect to that one and update that one. So when we're referencing the text component, we're referencing this component on our game object. Now notice how it's turning on and off the text, which is just this text field, which is just one data member of this component, this class. There's many other attributes, data members that's exposed to us, so we can change the font type, the font size, the alignment issues, all that we can change with code, or we can just do it in the user interface, which is just calling the code behind the scenes. But this text is referring to the component text, which happens to be just named the same as the text attribute. But we're first referencing the component. And then we want to update the text attribute, the string that gets presented to the user, which is this here. So if it's halfway there, we want to show something like 56. If it's really low, maybe we want to show like 23. So green amount.text, with green amount referencing this text component, the text component, we have to use the dot operator to reference the string that we want to change that's presented to the user. The next element is, well, what are we changing that string, that text to? So green is a float that will always be between 0.0 and 1.0. Well, I wish to present that information to the user to be between 0 and 100. So if I multiply it by 100f, or a float of 100, we'll go from 0.0 to 1.0. We'll move that to 0.0 to 100.0. Well, dot, blah, 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 blah. It's this long decimal after it. So to deal with that, I only want to present it to the user like an integer. So we can use the toString method, which is already built for us with every data type. So integers, floats, bools, vector 3s. You could do .toString, and somebody kind of figured out, well, what's the best string representation? So for a vector 3, it prints out the 3 floats with commas in between, I think. For a float, it's going to present out this decimal number with a long decimal part to it. But you can pass in some information, some parameters into this toString method call. And these parameters will actually kind of truncate, chop off the decimal wherever you want to. So if I did F3, it would show 3 decimal places after. So if it happens to be that we're kind of dragging the slider in the middle somewhere, this might give like 52.3927 or something. If you do F1, it'll truncate the decimals to just that 10th place. So you might get 50.1 or 70.2. But if you do F0, it just kind of cuts off the whole decimal part. So basically, it's like presenting integers to the user. So now we're presenting these integers from 0 to 100 without the decimal part to the user as this passive text part of our user interface. So in our click detector script, instead of updating this text green, which is the left side, I just built this right side of it. I'm just going to connect that as our reference. And when I click play, and I change this, we're updating the right side. And as you see, as I draw, there's a very low green amount. If I update that, there's a lot more greens. And so now we're giving some feedback back to the user what this slider is actually doing. And if I go in and switch back to the old green, now we're updating the left-hand side. So all the functionality is built out. I'm just saying which text element are we updating. And it's important to note that it's really like text.text. The class text dot the data member text, which is the string going to the user. All right. Is there any questions on that part? All right. I'm going to delete this button. I'm going to make sure that I'm referencing the right green, which I'm not. I'm going to connect that back. So the next thing to talk about is the time delay here, which in a similar fashion changes how long till we destroy something, but we passively show that information back to the user so that they know what this slider does. And the toggle's right next to it. So I feel like that's enough information to tell them that like the time destroy is off. You have to clear it out and turn it back on. So the toggle we went over, but I'm going to go over the slider for the timer. So this toggle also was separate, was a sibling to the slider. So if I ever had to move this part of the UI, notice how they all don't come along for the ride. So I actually kind of pulled this toggle in, and so at least that they all are one grouping because they all have to deal with the same functionality. So if you move them, it's very easy. Just grab the parent. Now as I hunt down here, we have the slider, which goes from 1 to 5, this element here. It was shrunk down a little bit than the other sliders so that it can fit this information on the side of it. It defaults to 3, a 3-second before destroy, and it's only on whole numbers. So if I click play, it feels like this slider is discretely moving between these integers. So if you don't want that functionality, just turn off whole numbers and it'll be a discrete or a continuous value change between these 1 to 5. But I like the whole number parts of it because the information I'm presenting back is a whole number. So otherwise it'd be sliding continuously from like 2.2, 2.3 up to 3, but I don't want to show all that additional information. I just want to show, well, you're going to destroy after 1, 2, 3, or 4 or 5 seconds, which is why I have a whole number on the slider. So this script is calling change time to destroy. This one. It gets passed in a float. Even though we have it restricted to whole numbers, I'm still passing it in as a float because our time to destroy is a float. And that's needed in this method call. This only accepts in floats for seconds. So even though I'm kind of restricting this to the user, we're still converting it back to a float because this method call needs a float to work. So this you're familiar with. And then this is new, and it's very similar to what we just did. The only addition to it is, yes, it's a button. It's deactivated. The button component was removed. It's white. You can change the color if you want. So I figured out I want it to be a whole number between 1 to 5. And I want it to say sec afterward. I don't want seconds. I think sec is enough for people to know it's a sec. It's a second. So we have this kind of static text element or string that we have to take care of every time because we can update this, but we're going to be passing in numbers like 1, 2, 3. So I want it to be about this size, so I kind of scaled the button image down to fit it and positioned it. And again, we made a text reference here called timer amount. And if I look on click detector, it's this one here. I just connected it to our text timer. And down here we say timer amount.text. So here's the text component. We're going to go down and grab the text attribute. And we're going to set it equal to this. So whatever this float is, time to destroy, we're going to use its built-in method toString, and we're going to say cut off the decimal part of it, F0, give us none of the decimal places. And we have to concatenate onto this static string. So this number is always dynamic. Then we're going to add on to it this little string bit, which has a space and then says sec. if you don't put that space, the 3 in the set just like there's no space between them. And that's how we get this little text element to update whatever second set we want to show the user this is what you currently have selected, and your paint stroke will disappear after that much time. Cool. So does anyone have any questions on the user interface and how I'm kind of changing the information to present it to the user in a more concise way? All right. So let's go on to the paint stroke because right now it's not connected in any way to the time. So I can talk about how we're changing the painting information without moving to what the clock and the time is doing. So to do this, I needed to switch from, I was using these calls, these gameobject.create primitive, and I'm using this Unity built-in method that just is spawning these default primitives. I'm still going to be creating spheres, cubes, and cylinders, but I'm getting a little bit more customized with how I'm changing the material attributes, how I'm messing around with transparencies and emissions. So now I'm going to have to completely move over to spawning prefabs, spawning my own game objects that I've saved out as files, and I'm not using Unity's built-in methods anymore. So to do that, I'm going to create some public game object references. I'm just calling them painted object 000102, just because that lines up with case 0, case 1, case 2, sphere, cube, cylinder. So to create these prefabs, I'm going to go game object 3D. Spheric is the first option that I create. I'm going to zero out its position because when you spawn it, you don't want any additional position information. Wherever you click, there's no offset to it. It gets spawned right there. To do that, the position needs to be zeroed out. It's got a mesh render on it, which is great. You can see it. It's got a collider on it, which is great so that it knows when you click on it, we can do something to it. There's 2 more things we need to do to our prefabs to make this new system work. One is we're going to have to create a material. And 2, we're going to get a little bit more choosier. We need a little bit more information on what we're clicking on. So I don't know if you remember last week, but I started to make the clock interactable, or I was trying to figure out how to make the clock interactable. And if you notice, when I was clicking on parts of the clock, it was deleting those parts. That's because the hour hands and the hour indicators are cubes that have colliders on them. And so I need those colliders because I'm going to click on the different hour hands to move the time around. So I'm still going to use this this mechanic where whenever there's a user input, a click of some kind, we're going to cast a ray out, and if it hits something, if it hits a collider, we're going to do something. But now I need to know what type of collider I'm hitting. So I need to introduce the fact of these layers here. So if you just click on any game object in your scene, in your inspector, you'll see that there's layer. And by default, you're just on this default layer. There's no separation of objects. But we're going to create our own custom layers. So we go down here and we click Add Layer. Notice how there's some built-in layers. Unity provides these. They're used very frequently. So they have to deal with like ignoring ray casting and user interfaces. That's great. If you come down here, you can create your own layers. So the ones for this class that I'm making use of right now is clock. It's a part of a clock. I just call it clock face and painted object. So I'm making 2 custom layers. One that I'm going to place on my clock parts. I'm going to go through all my clock parts and say you are part layer clock face. And these painted, these spawned prefabs I'm creating, they'll have a layer selected for them. They're going to be of layer type painted object. So now I can do a check. whenever we do a left click or left hold, we shoot a ray out, and if we do hit something, we can do a check. Okay, I hit something, I hit a collider. Which physics layer, which layer does this object live on, or does it belong to? Is this object on layer of type painted object? If so, go ahead and delete it. If this object is of type clock face, if so, we need to update the time. So as I'm creating these prefabs now that I'm going to be using to instantiate, to spawn, to paint, I've created a new layer of type painted object. Just take note of the number. So for example, layer 11 is reserved for my clock face. Layer 12 is reserved for my painted objects. That's how we're going to reference them in code. So this sphere, now that I've created a custom layer, called it painted object, I'm going to select that layer. And I have to create a new material because when you instantiate these Unity default objects, there's only so much you can mess around with the materials, and that just happens to be a color. Now we're going to move on to transparency and emission. So I'm going to select layer painted object, and I'm going to go up into my project, and I'm going to create a new material. And I already have it created. I call it painted. I'll call it like painted 02. But it's going to still be a type of standard shader. But now we're going to go from a rendering mode of opaque to transparent. So opaque is a lot cheaper to deal with render-wise on your graphics card than transparencies, because you have to look behind this object, what it still exists if it's transparent, and render these objects as well. So by default, this functionality is not offered. So go to rendering mode, transparent, and turn on emission. These are some new things we're messing around with. So if you notice my painted material, it's transparent. I'm going to drag it onto this sphere. And let me turn off, and let me make emission black so that we're not showing it right now. Let me bring up alpha. So this is something that you might be used to looking at. You can change the color on this object, right? So now that it's transparent, we have the fourth attribute of color, A. Remember, we're creating vector 4s, 4 floats, RGB A. Now we can actually make use of A. We can lower the alpha. We can make it transparent. Now this object is, you can mess around with these things if you care to, but what we're left with seeing is the reflection, the shine is left. So now it looks like bubbles or glass or what have you. But it's really the reflection of the environment is what's left if you were to pull it all the way down. I'm not going to do that though. I'm going to leave it somewhere midway. Just make it a little bit transparent, because when you do that, you can have a lot of fun with the emission. So you can make it look like it's glowing. All right. So when you have the emission color different than whatever it's being drawn, the albedo, the diffuse, you can get some interesting effects, and you get these color mixes, and it's great. And that's actually like car paint shaders are done with a lot. If you notice that when you look at cars, if you look in different light, the paint kind of changes color a little bit. And in computer graphics anyway, it's how you can kind of mix colors in one way of doing it. But I'm going to, whenever I spawn an object and I make a random color, a random red, a random green, a random blue, I'm actually going to reuse that information, just lower it down and put it in the emission. And that way, if it's, no matter what, if it's bright out or dark out, you always get these good looking paint strokes. So I'm going to leave this color information as it is. It doesn't matter, because when you spawn the object, you're going to overwrite this information with your code when you do these random number generators. All that's important is that this material is transparent and emission is turned on, and you drag it onto this object. So I'm going to delete painted O2. I was just showing you how I made this painted material. What's important on this sphere, position is zeroed out. It's on layer, painted object. It's got a collider, that's great, and it now has this painted shader, this painted material that we can now have more attributes that we can mess around with code-wise. So when we've built our prefab, I'm going to move my hierarchy down here because I need access to both my project view and my hierarchy to create the prefab. So I've already created a sphere, a cube, and a cylinder. I'm going to delete them because we're going to recreate these files. I'm going to drag the sphere in. So now it's a prefab. It's in our project. It's an actual file on our hard drive. So I'm going to delete the sphere game object, the instance of this prefab. I don't need it anymore. So now I can create a cube, zero out its position, put it on layer painted object. A few of you weren't in the other class anyway. As you're recreating your prefabs, make sure they're all on layer painted object. They're doing it for like the first one, and then they stop doing it for the other prefabs. Your prefabs can be different. Remember I was showing you can like duplicate out geometry and like offset them, put them in a parent, rotate them, put different materials on. I'm still sticking with just the one object, but you can get fancier. But all your objects, will need to be on this layer for this system anyway. And we have to go up and give it the material that we want. Painted. All right. So it's got the material. It's got the layer. The position zeroed out. We're good. So I'm going to drag it into my prefabs folder. Now we have cube and sphere. I'm going to delete this cube instance. Go to cylinder. Zero out its position. Put it on layer painted object. And give it the material. Painted. All right. These are the steps for creating these prefabs. And now I'm going to go to my prefabs folder. Drag this in. Oops, no, I don't want to overwrite that one. I want to put it, make sure that little icon looks like I'm in between two objects. Drop it in. Sphere, cube, cylinder. On my file system. Good to go. All right. Now, if you remember, I created in my script these 3 game object references. So I'm going to go back to my click detector. Here they are. Painted object, double knot 1 and 2. So just the order I'm working with, it's sphere, cube, and cylinder. The only reason this is the order is because that's just the way my drop-down list was built. Yeah.
Could you show like the transform numbers for the camera? That's like 9.
Oh, yep. It should be something like this, like position Z is -10, and the rotations are zeroed out. And then as we're placing stuff at world space 0, you're able to see it. Because you're pushed off of world space 0, looking at world space 0. Good? Okay, so what did we just do? We connected up the 3 prefabs. We put them on certain physics layers. We gave them a new material.
So each painted object is a different layer, or is it just painted object?
See, they're all on the painted object layer. The point of that is whatever you're spawning, I'm just calling it painted, is that they're all on this same layer. That way we're going to do a check, which I'll show you now. So if you remember, my input statement was if you left click or left drag, if input get mouse button down 0 or get mouse button down or get mouse button 0, if you either click left clicking or left dragging, we see if we're clicking on something. The issue I was getting with that is when I was interacting with the clock, I clicked on an hour indicator to set the clock to that. It wasn't just reading in that one click, it was clicking the drag. So it was like I was clicking on that hour hand over and over again. So I separated out my user input now. So if there's a left click, if it's an input get mouse button down, we're only checking, and if a physics interaction happened, if we clicked on a collider, we're only checking if that collider was on the clock face. And if so, we do this method call to update the time. So I'm going to get into this in a later video, but know that it didn't make sense to have basically like rapid fire or holding down available on the clock face. You only want to do like a left click. If you click on an aspect of the clock, we're going to update the time. Now for deleting objects, it made more sense to be a left hold or a left drag, because that's basically what I was doing. I was saying either there's a left click or you're dragging, then we're going to delete. Either case will lead to deleting an object if we're clicking on an object. Well, that's basically, a left click initiates a left drag or left hold, so it's like you're doing this mass deletion anyway as you're dragging over stuff. So let me just, and that makes the most sense anyway. So let me switch over to say if we're currently holding down the button and we're over stuff, we start deleting it. So this you're familiar with. We do a right cast out. If we hit something, we're going to destroy it. But we do a check. If we're left holding and we're holding over a physics collider, and if that collider happens to be on layer 12. So in this case, you can't reference layers by their name, by their string. You have to reference them by their array position. And you can do that by just opening up layer and see that here's the numbers associated with each layer. So if this collider is on layer 12 or the painted object layer, then we're going to go ahead and destroy that object, right? And then later on, the online videos, I'll go over this here. If we're doing a left click and we're clicking on a collider that's part of the clock face, we're going to run this update time method, which will be for later. I just wanted to make apparent why we're putting stuff on these layers so that we know what we're clicking on, because now I'm clicking on other stuff that has other functionality, the clock. So as I move down here, instead of these primitive equals gameobject.create primitive and then whatever primitive from the enumeration that's available to you from Unity, we're going to instantiate. So case 0 is the sphere, which is painted object 0, 0. Case 1 is the cube, painted object 01. Case 2.
Where do we write the...
Oh, yeah, up here. Public game object, painted object 0, 1, and 2. And then these are what I dragged my prefab on. So these are references to the file, to the prefab, not the instantiated game objects. And so based on whatever drop-down list we have, if there was user input or this right-clicking, which I might switch up later. Interestingly, this not only does this run on web, but it runs on mobile too. You just get like this little pop-up that says this isn't supported for mobile. But if I switch this over to on mobile, if you hold down 2 fingers, that's like a right click, it actually works. But if I switch it up to just left click, which I'm going to think about, you can actually paint with 1 finger on mobile. Anyway, switch on shape. Shape defaults to 0. So we figure out which prefab now, not Unity default primitive. These are my prefabs that have the new material and the new physics layer connected to them. So instantiate allows us to specify the location and the rotation of where to place this object. So click position, which we were doing down here. I commented that out because now we can just throw that information into our method called instantiate. And quaternion identity just means a rotation of 0. At either case, we're creating these objects, and the next major part of the code to talk about is this section. How we're creating the color, and then how we're creating the emission color. So this line you're familiar with. This is creating a bunch of random ranges and passing it into our color channel. But it used to be go to the primitive, get its render, get its material, get its color, set it equal to a new vector 4. And I did RGBA and then set alpha to 1. Well, since we're dealing with colors, I thought it would be better if we deal with the correct data structure, which is of type color, which is very similar to a vector 4, but it just has some additional features in its class that deals with the fact that it's a color. So what I did was, we now have two private color variables, one called painted object color and one called painted object emission. And one's going to set our color, one's going to set our emission. And the reason I did this is because emission is going to be based off of color. So for me to connect the two together, do some math with them, it'd be easier to show you if I just made them distinct variables. So the code should be easier to read. So down here, I'm going to maximize this because this line gets a little long. Okay. We're saying, okay, we created some object. We know that it's, we're going to set our painted object color equal to a new color, not a new vector 4, but same information goes in. Random range from 0 to red, random range from 0 to green, random range from 0 to blue. And instead of 1, meaning fully opaque, I'm just doing 0.5 right now. So it's semi-transparent. RGBA. That information gets put into this painted object color. That's what we're going to pass to our color parameter. And it's actually going to update this new object's color with that information. So the reason I have it as a separate variable, this color variable, is that I'm going to use it here because I want to base my emission off of those random red, green, and blue values, but I want to lower them down. So when emission gets fully on, it gets really strong. So if I click play, and this emission strength, which I'll get into, but at 1, notice that they're kind of strong, almost like neon, and there's a lot of whites in there. And so pulling down that emission strength, where it's just kind of a fraction of the color, works better. And in the daytime, it works better to be at a lower fraction. And during the nighttime, it works better to be a higher fraction, more glowy, right? So to do that, the emission is going to be a new color. This color has 3 parts, RGB. There's no alpha in emission. So you can create a new color with 4 parts, which the 4th is alpha, or you can create it with 3, and alpha is ignored. So here for red, I'm saying go get me the red channel from our color, which we just did a random roll and found whatever that is. Multiply it by this emission strength, which is going to be a fraction. So go find me the green color that we have spawned from our color, multiply it by some fraction, so it's not fully on, so it's not like this blown out white. And also, since we're multiplying it by a variable, I'm another step closer to either connecting it to a user interface, which you just saw in the inspector. I was messing with the range, or eventually it's going to get updated by the clock, by the time. Wherever the sun is at, it's going to impact how strong this emissiveness parameter is. And then go take the blue channel from color and multiply it by this emission strength. Once we're done with that, we go primitive, get component renderer, get the material, and then we're calling set color method. And set color needs a name of the parameter that we're going to change, and then the value that we're going to change it to. So this is actually being called here when we say material.getColor or material.color. We're using a setter function. It's just kind of hidden from us because setting a color is used so often. It's kind of like dot transform. Behind the scenes, it's really saying dot get component of type transform. But since it's done so often, there's been a setter function and it's been simplified, the way that you write it out, which is why color can just be set like this. But since emission color isn't exposed in that way, we have to use the proper method call, which is a little bit longer. It says we're going to set a color. What color are we going to set? It's going to be called underscore emission color. And what are we setting it to? Well, it's this color variable that's called painted object emission. So if I go to the shader, say edit shader, this actually shows behind the scenes all the properties that you can change. So just know that by default, here's underscore color. That's what you're setting all the time with dot color. And here is underscore emission color, which we're using that set color method to set. That's why we have to specify its name exactly as a string. All right. The only thing I didn't cover yet is building this emission strength variable. But it should be, I'm trying to get you to see that we're setting the color just like we always were, but we're reusing that information. We're just reducing the values, but keeping the same relative strength between RGB so that the same hue is shown, but in the emission, but we're just dampening it down because you saw that emission can get really strong. And we also want to manipulate that based on the time of day. So this emission strength looks like this. Yes, it's a float. I made it private. I defaulted it to half a unit. But I also made it a serialized field, so that's exposed in the inspector. And I also put a range on it, clamp it down so that whoever's manipulating it in the inspector can only go between 0.1 and 1. So if you want, I could actually do 0 to 1. You can fully turn emission off if you wanted to. So maybe I'll do that. And that allows me to update the strength of this emission real time, so it lets me play with what makes sense. Yeah.
If you want to use the prefab, you have to change the word primitive on that code.
Yeah, so primitive is another. In this case, it's a game object reference, but it's private because we don't need to connect anything to it in the inspector. So these game object references are actually referencing the prefab, the external file. This actually references the instantiated game object in our application, which only exists in memory. It's dynamically created and it's destroyed when the application stops. So that's how we can spawn multiple copies of this prefab at runtime. But we need to know what this prefab is. And these are links to the prefab, like file locations. And even though this reference is they're all game objects, they're kind of, one is saying here's the location on the hard drive of the permanently saved game object, which is called prefab. The other one is a reference to the temporary, the dynamically created and destroyed instances, which we can get hundreds and even thousands of. And so, yes, primitive is referencing all these instantiated copies that live in memory, not hard drive. And so that's what primitive is. That's why when we're messing around with the scale, the color, the emission, the location of primitive, it's not really the stored version. It's these copies that live temporarily. So that's why primitive changes its color to this random generated situation, and whatever primitive, whatever this instantiated copy is, change its emission color. That's why I don't care what this painted material is defaulting to with red and this emission color, because it's going to be overwritten. These materials are going to be made copies of, and then those numbers are going to be overwritten by the instantiation. All right, so we got like 20 minutes, and that is how I'm updating the color and the emission. So let me actually pump the emission, or allow the user to pump it up to 2. And let me just see how crazy it looks. And you'll see how it should just get like all washed out into whites. So I can drop it down to 0. Doesn't have any emissiveness on it. Pump it up to 2. Oh, like they're super like neon. All right. So sure, if you want to try maybe 1.6, I don't know, they're getting pretty strong. But you can, now you have your little developer user interface, you can kind of figure out which numbers make sense to expose to the user. All right, so before I move on to the light source, did color and emission make sense? And transparency?
Would the emission slider count as a new feature?
Yeah, build it out into the user interface. Yep. And it's exposed to the user as a feature, sure. I should probably expose out the transparency. Right now it's just hard-coded. The next step would to make it a variable. You then expose that a variable into the user interface. So I went over these prefabs and how to make new material changes, and that it's important to understand that we're creating layers now so that we can check which type of collisions, what are we clicking on, and based on whatever we're clicking on, we change the behavior. So here we're just worried if it's a painted object, and in the online videos I'll go over this part, how we're updating the time. So for the remainder of the class, I'm going to go into how to set up the orientation of the light source and then connect it to the clock, or the time. And that'll start with the first clock feature, the first time feature. So let me check which clock. Yeah, I have this one. This is the right one. So I'm going to talk about this first feature, which is we can turn off real time, and with this slider we can designate which part of the day cycle, which part of the 24-hour day cycle are we in. All right. Before we can get to that, we have to figure out a convenient way to rotate the light source, which is why it's in a parent right now. So if I pull it out of the parent, and if I put it at rotation 0, you can see it's sideways. This is kind of either dawn or dusk. So it's kind of like 6 a.m. or 6 p.m. So now I think about, all right, we feed in these hours. The hours go from 0 to 24, 0 to 23 technically. And I would like that to impact how this sun is rotating. So I would like the sun to rotate at hour 0, which means midnight. I would like the sun to be, first off, I start rotating the sun. And I figure out, oh, okay, it's the X rotation that matters. Whereas on the clock face, we were rotating on the Y. First off, I figured, okay, whatever I do, I need to rotate the sun on the X. Now, I would like it to be pointing up at midnight. So it's like on the other side of the world, it's like noon. For us, it's like midnight. And I figure out, oh, okay, it's a rotation of negative 90. That's kind of messy. And somehow I'd like it to get around here when the sun is rising or setting. And then somehow I'd like to get it around here, or high noon. If I look up, the sun's right above us. And somehow I would like to continue on its journey around 6 p.m., sun setting. And at midnight, or at hour 23, getting to 24 to reset, I would like it back at midnight to do a full rotation on a 24-hour cycle. So I really care that it's pointing up at midnight, pointing down at noon, and I don't really care about east and west. I don't care if the sun is rising east or west and the sun is setting. What is it? Sun sets in the west, rises in the east. Nobody really knows anymore. In either case, we're in this virtual world, so I don't really care about being real to that. The user doesn't even know if they're facing east or west. All I know is I want the sun to be vertical at 6 a.m. and 6 p.m., some type of what I would like to be 90 or negative 90. And to make the math easiest, when the hour is 0, I would like the rotation to be at 0, and I would like the sun to be pointing up. At hour 12, I would like the sun to be pointing down, and I would like to be at like a rotation of 180. And as the sun is coming back to midnight, as our hours are getting back toward 22, 23, 24, I would like the sun to be pointing back up, the rotation to be getting back to like 340, 350, back to 360 for a full rotation. So I know that a negative 90 gets my sun at midnight, hour 0. This is my starting point. But this math is ugly. I don't want that. I don't want to have to deal with this offset. So if I make another game object and I call it daylight or day manager or day parent, whatever, I know that if I put its rotation x at negative 90 and put the light source at negative 90 at midnight, pop it in, the local rotation of the sun becomes 0. So let me pop it out again. Negative 90, 0, because the parent is set to negative 90. So now, just looking at its local rotation, I could say, okay, rotation x is 0 is midnight. Rotation to 90 is 6 a.m. Rotation to 180 is noon, or hour 12. Rotation to 270 is 6 p.m., or 18 hours. And rotation to 360 is hour 24. So the math is easier for me. In fact, it's almost like dealing with the clock face. So that's why I did this parenting situation. I made the math super easy for me. So on our clock script, all this information or all this features, a lot of it you've been exposed to. This is through the clock tutorial. We're feeding in the system time. We're updating our clock face, our minutes, seconds, and hour hands based on whatever that clock information is. Since I have access to this time information, I can update my sun now. So I need to know about the sun. So I can do public transform day cycle. So the transform is I don't need to connect to my light source at the game object level, because all I'm going to do with it is rotate it. So I can just save myself a step, say I'm going to connect to its component transform, so then I can just manipulate its rotation one step closer. So public transform day cycle, and if I click on the clock script here, all I did was connect my light source to that reference. Now I know about the clock. And so on the awake function, which we read in the discrete time, which the second script I switched completely over to the continuous time, so we get those like fractional movements, those continuous movements of the hour hand and minute hand. But for now, I'm doing the discrete time, and in the online videos, you'll see I'll switch over. I'm updating the hour hand, the minute hand, the second hand. Local rotation, I'm grabbing a quaternion dot Euler. Euler is a rotational math structure that we're all familiar with, 0 to 360 rotation. The hour hands, minute hands, second hands, we're rotating on the y-axis, so x and z are 0. For the day cycle, we're going to update its local rotation. We're doing the same quaternion Euler, but this time we're manipulating the x part of the rotation, not the y. So y and z are 0. Now what we're doing here is we're feeding in the hours, which is an integer from 0 to 23, and we're multiplying it by our degrees per day cycle. So to deal with the hour hand, which swept across the clock face in 12 hours, did a full rotation in 12 hours, we did 360 divided by 12, which was degrees per hour, which came out to 30. So if we move 30 degrees per hour, we'll go full 360, a full clock face, in 12 hours. The sun is a little different. We just want it to move half as slow. We want to go 360 degrees in 24 hours. So we want to move half as much. So 360 divided by 24, we want to move 15 degrees per hour. So the number is related to the hour hand. It's just half as much. So to rotate the day cycle, we're rotating on the x instead of the z. We're feeding in the hours multiplied by 15, our degrees per day cycle. Then whenever we awake or run the function, run the application, the sun, since we've adjusted it, offset it with a parent object, will now rotate the way we care to based on 24-hour cycle, with midnight being pointed up and noon pointing down. And we do the same in the update loop. So we have this addition here of if real time. So real time is just a bool set by default to true, because by default we're just reading in the system time, and we're not manually changing the hour. So if real time, which we default in, we update the hours based on system time, and we set the time to that, the rotation of the sun. We feed in the hours, multiply it by degrees per day cycle. Else, meaning we went here and clicked this off because we want to do our own hours, we have this now. So we have an integer. It's in the inspector. Make it private with serialized field, but there's a range on it, 0 to 23. So when we awake, that's updated. Whatever the system time is, that integer gets updated. And if it's real time, it's always just being updated by system time. If it's not, if we turn off real time, we're going to be able to affect the lighting situation based on this integer, which we can manipulate. Right now, I'm not impacting the clock. The clock is still being driven by system time. I just am showing that we can now start to change these parts of our system dealing with the environment time manually. And eventually I'm going to get to, you can start clicking on the clock and updating that all. But if you click play, clock gets updated, environment gets updated, the sunlight. I can turn off real time. Right now, real time, I can't drag this because it's constantly being updated by system time. Turn this off. I can now impact or override or change the lighting by myself. As a developer, I have my own little user interface. So this is a good way to test too. To say, okay, if it's hour 0, does this look right? 3, 4, 6 in the morning, 8 in the morning, this is noon. Here we're getting toward evening, 6 p.m., the sun is setting, and we're back into night. So I'm testing the actual math with my own little interface, making sure that everything is correct, all these different use cases. That looks good, but I can also set the time and see how the painting stroke is working out. All right. So we're getting closer and closer to kind of sewing all these systems together. So eventually I'll turn this off, turn this on. We'll get to the point where we can update the time directly on the clock. We can swap out whether it's AM or PM, just changing it 12 hours. Or we can click on the time that we specifically care to right on the clock. And this is changing the environment sun, and it's changing the clock. The next thing I have to sew this all together is connecting the emissiveness of this stuff based on the day of time. So this next script I'm doing here, this clock script, which is letting me click on the clock, I'm going to cover in an online video. But it's being driven by this click position manager when we do input, when we left click, and we're clicking on a collider as part of the clock face layer. Then we're going to go out, find the clock, and we're going to call the update time method based on the rotation of each of these little clock parts, which I'll cover in another video. And then next week I'll tie together like changing the emissiveness of this or the transparency of this based on the day of time. All right, so I just covered how to connect the time of day to, well, how to update the daytime, the sun rotation, so it's super easy to drive the rotation of it. And I then connected the actual time to that rotation, very similar to the hands on the clock. And then I showed you how to create a situation with a bool and an int to then have a little slider to update the time yourself. And then I'll cover this script where it's like you're clicking on the clock. You don't need that UI slider anymore. You can just click right on the clock and the little AM PM timestamp. And that'll be online. So is there any questions so far before I wrap this up? All right. I'll just go back to Moodle briefly and remind you that we're here. So you have a week of work, another week of work. You got spring break. This should just be little fine tuning, get your app up for delivery at the end of spring break. And probably next week, one of the videos is as I near completion of my app. I'll build it, put it up on itch.io, and I'll show you how to. I'll go through the whole process of creating the posting again, just like last sprint. And then sprint 2 deliverables at the end of spring break. And then we move on to sprint 3, sprint 4, and we got our final. All right.